All right, welcome to this session on EC2 Image Builder. This is a brand new service that we announced on Monday. My name is Samartha Chandrasekhar. I'm a product manager in our compute services organization, and I'm extremely excited to walk you through EC2 Image Builder and give you a rundown of its capabilities. Before we get started, I want to do a quick poll here. There is a fun but polarizing topic around how you say sort of the abbreviated form of Amazon machine image. There are really three options that come up. There is AMI, there is AMI, there is AMI. So quick show of hands, AMI, how many folks? All right. AMI, all right. And then AMI, no one. All right. There isn't really a right way. Whatever you, there is no official guidance per se or any of that. Whatever you think is the right way is really the right way. But just wanted to see where you guys are at. All right, with regard to agenda for this session, I want to talk about the importance of golden virtual machine images, the pain points that we have heard from our customers with regard to building customized golden virtual machine images, especially around keeping these things golden as sort of updates are available. And then I want to talk to you all about how EC2 Image Builder helps with this process. And finally, I want to go over usage workflows and actually show you a working demonstration of EC2 Image Builder in action, and finally go over certain best practices and end with a Q&A session. So let's get started. Golden VM images. Now before we get started, how many of you all customize your image from the stock virtual machine image that the OS vendor provides you? All right, nearly all of you. So do I. This is where this concept of golden virtual machine images comes in. So these are customized virtual machine images that come pre-installed and pre-configured with all of the software, the scripts, the configurations that you want as your ideal state. And many of these are hardened to meet with either internal or applicable industry regulations that you might want to meet. Furthermore, and most importantly, these are also sort of templates that you can spin up multiple virtual machine images from. This notion of golden virtual machine images is also a very core construct to our take on immutable infrastructure. Our recommendation is that you typically don't update running virtual machines in place, but you essentially build new images with all of the latest updates applied and then use that as your as the basis to spin up new virtual machine images, new virtual machines that is. And thus golden virtual machine images become the basis for immutable infrastructure and hence form a core part of sort of running your compute infrastructure efficiently. Now, nearly every organization that we've spoken to has had to build these golden virtual machine images. However, there have been lots of pain points that we've heard from our customers. And there really are two primary categories of customers that we've heard from. There is a category for whom just the skill bar of writing custom automation or even using an existing automation framework just represents too high of a bar. And they're looking for a simplified solution, perhaps a console-based UI wizard to be more productive. And then there is the second category who actually have the skills to use advanced automation frameworks. However, they don't want to do the undifferentiated work and the heavy lifting of hosting these automation frameworks, managing them, etc. Furthermore, we've also heard from our customers that they want testing of virtual machine images to be treated as sort of a primary construct in this workflow. Because from what we've heard, the vast majority of service disruptions that we've heard that our customers have experienced have been due to errors in the VM images that they deploy into production to run in their virtual machines. And much of this has been due to inadequate testing or the testing processes being suboptimal, etc. In many cases, we have customers who manually test some of these images and then sort of manually vet them, get them past compliance teams, etc. And as you might already be aware, most of what we do is really working backwards from our customer pain points and answering what our customers have told us. And here's essentially a small list of what formed the basis of the customer feedback that inspired the birthing of this service. So we heard from our customers that they want to be able to quickly and easily automate the creation of these golden virtual machine images. Furthermore, these golden virtual machine images don't stay golden for eternity. They convert to a lesser metal, if you will, as soon as there are pending updates, and then you're no longer golden anymore. So there is the automation was not just needed to produce the VM images once, but to produce it on a continuous basis in an automated fashion as updates are available, not just to the underlying OS, but also to the constituent components that get pre-installed. The second big part of what we heard was around testing. So we heard loud and clear that testing needs to be a first-class construct. Furthermore, our customers asked us very strongly for AWS provided tests. Now, we at Amazon have lots of experience with building and testing virtual machine images. We ship our own Linux distribution in Amazon Linux, and we have an extensive suite of tests that we run on Amazon Linux. And it's not just restricted to Amazon Linux, but we also build and ship and manage and curate Windows Server images, and we run our own tests there to ensure that they run great on EC2. A lot of our customers were aware of this, and there was a strong ask for AWS provided tests that they can readily use, in addition to, of course, custom tests. And finally, the same construct also applies for security hardening. There are lots of industry standard baselines for security, and we heard from our customers around the need for AWS provided templates that provide at least a good starting point towards meeting some of these common security benchmarks. And finally, we got a lot of feedback around the ability to make it easy or the ability to distribute and share images across regions, across accounts, etc., and to simplify that experience. And finally, to not make a solution that is sort of that only works for AWS, but also to be able to export these virtual machine images for use on premises. And similarly, the ability to onboard virtual machine images that you might have built for on-premises use to AWS to further distribute into multiple regions, etc. And essentially, I introduce you to EC2 Image Builder, which is a service that essentially addresses all of what we just went over. This is a brand new service that, again, like I said, we launched on Monday. It makes it quicker and easier to automate the creation and deployment of up-to-date and secure virtual machine images, not just for use on EC2, but also for use on premises. There are really three themes here about this service. The first one is around automation and the ease of automation. The second one is around security, and the third one is around testing. So when it comes to automation, we have an intuitive, easy-to-use UI wizard that you can use to automate, to build an automated pipeline that will keep your images continuously up to date. Furthermore, you can also use, anything that you can do in the UI, you can also, consume the same functionality via our CLI or our API. In fact, there are more powerful capabilities that you can consume if you actually use the CLI or the API. The UI certainly does make a strong effort to abstract out some of that complexity. Secondly, security and AWS provided primitives for security hardening is a core part of this. So we see this as an integral part of your image build pipeline, where you actually harden your images before you deploy them into multiple regions for production to either raise your security bar or to comply with internal InfoSec stipulations or perhaps industry standards that might be applicable to you. And finally, we also make it possible for you to test your images before they're distributed out for use in multiple AWS regions that you select. Going ahead, in addition, we also provide centralized policy enforcement. So the EC2 Image Builder service integrates with other AWS services, namely Resource Access Manager, that allows you to share multiple aspects of EC2 Image Builder across multiple accounts. For example, you could share images, you could share pipelines, you could share this construct that we call recipes that I'll get into in just a little bit, which is sort of the definition of these automation pipelines, etc., across multiple accounts. And really the intent here is to be able to chain these recipes. For example, you can have, say, a use case where there's a central IT team that is in charge of building, say, golden VM images, and there are, say, other divisions in the organization. Let's say there's an HR team, for example, who picks up this output of the pipeline that is produced by the central IT team. Then they take the images from there, add their own customizations, run their own tests. But the image that they're starting with is a blessed golden image that comes out of the central IT team. And subsequently, there could be further downstream scenarios. Again, that HR department itself could have multiple divisions, etc. So we allow for those chaining scenarios where the output of one pipeline could be the input of another, and so on. And you know, the ability to share artifacts through Resource Access Manager certainly does make that possible. Subsequently, the service also integrates with AWS organizations. So if you have multiple AWS accounts, you can again perform image management and lockdown and policy enforcement using AWS organization. A canonical example that we've seen to be common is one where there's an AWS master account associated with AWS organizations, and then there are subsequent member accounts. And the master account can go ahead and enforce policies and restrictions such as thou shall not start an EC2 instance with anything but a blessed golden image that the master account has approved, using service control policies and things of that nature. Subsequently, you can build golden virtual machine images, not just for use on AWS, like I mentioned, but you can also use it for use on premises. Currently, as we speak, it requires an additional step by using VM ImportExport, which is another capability that's available in EC2. So you can import existing VMDK or VHDX or OVF files that you might use for on-prem VMware or Hyper-V or KVM deployments, bring them into AWS's AMIs or AMIs based on whatever your preference is, and customize it, secure it, test it, distribute it, etc. And similarly, you can spin up a pipeline using EC2 Image Builder, and the output AMI, you can export it as a VHDX file or a VMDK image, etc., for use on premises, again using VM ImportExport. We support both Windows and Linux. In fact, any AMI that comes pre-installed with the SSM agent is something that we support. As V1, as of right now, we have guided, curated experience with sort of first-class constructs for Amazon Linux 2 and all versions of Windows Server after 2012 R2. Moving ahead, in terms of the overall image build workflow, what you see here is sort of what the workflow looks like. So you would start with a source image. This could be an AMI that your account has access to. It could be one that's created by you, or it could be one that is shared with you, or it could also be this notion of what we call a managed image. So the output of an image builder pipeline is what we call a managed image because it is kept up to date. Now, AWS provides managed images, and you can use that as a starting point because you can be rest assured that the latest updates are applied there. Subsequent to that, you can stipulate the customizations that you want performed on this image. We have this notion of what we call build components, and this could represent software that you want to have installed. It could represent scripts that you want run inside of inside of the OS during this image preparation process, or it could be configurations that you want applied. And you can capture these in what we call build components. As AWS, we will provide you with a certain curated list of build components based on commonly used sort of pieces of software that we see installed in our images. But there will also be the ability for you to add your own components. Subsequent to that, there is the security and hardening step where you can secure your images to meet with either internal or industry specific criteria. Again, as AWS, we are providing primitives for STIG hardening. So this is again a compliance standard that applies to lots of customers in regulated industries, and we plan to invest in this area and expand in terms of adding more compliance stipulations that we provide out of the box here. Subsequent to that, you can test your images. Again, there is the ability to choose AWS provided tests, or you can onboard your own tests by authoring your own tests, and I'm going to get into some of the details of that in just a little bit. And finally, after your image is customized, secured, and tested, you can choose to distribute it to to the AWS regions that you wish to share it with, or you wish to distribute it to. You can also provide launch permissions for specific AWS accounts that you'd like to allow the ability to launch these images. And most importantly, you can configure the pipeline in a manner that ensures that the entire process repeats every time that there are pending updates, not just to the underlying OS, but also to the individual build components and also for the individual tests. For example, a test could have changed, or there could have been an improvement to a test. So that itself could trigger an automated rebuild. Furthermore, you can also go ahead and stipulate a build cadence or a build schedule where you can say, for example, every Tuesday at a certain point in time, rerun this pipeline with all of the latest changes, so you can be rest assured that your images are secure and up to date and have all of the latest changes. Another point here before I transition on is that all EC2 Image Builder operations run inside of your AWS account. So we spin up EC2 instances inside of your account to perform these customizations. And this includes both the customizations when it comes to installing software or applying configurations or running scripts, as well as running tests to validate your images. Now, I want to get into each one of these sort of subsections in a little more detail. So let's start with the AWS provided build components here. So again, like I said, this is a curated list of components that we have included for use with EC2 Image Builder based on feedback that we've heard around what our customers frequently add. This includes software that you want to have installed on both Linux and Windows. It includes hardening primitives and hardening scripts. It includes a whole suite of tests that are really based on the tests that we have historically been using internally to validate and test our own images that we've now made available through the service as well. In addition to the AWS provided build components and tests, you can also author your own components. And really there are two types of components here. There's a build component and then there's a test. And we have a declarative YAML-based specification document that allows you to stipulate the list of actions to be performed. And to make that simpler, we have sort of these action verbs that you can use in this declarative specification. And later on, when I get to the demo, I'll show you some real-world examples of these that you can look at and reuse, etc. But really, there are three categories of these actions. There is the ability to execute either binaries or scripts. It could be a bash script or a PowerShell script. There is the ability to reboot and update the OS, and that's treated as a first-class construct. There's the ability to transact with S3. So, for example, you can have a binary located in S3, and then you can pick up that binary, install it, etc. Similarly, you can write logs and other artifacts based on what happens during your installation back to S3. So that's a core primitive. And for Windows, we have a mechanism to manipulate the registry. That is also a core primitive here. Finally, we also have, for each of these build components and tests, there are a number of artifacts associated with them. There is a document.yaml file, which is how you specify this declarative list of things that you want achieved. There is a detailed output that you can later go examine, and you can look at the specific details of each step. If you have any sort of standard out or standard error console messages that you want displayed based on how you author your document, you can go examine that in that console.log file. And then there's also another application log to help with advanced troubleshooting and debugging that I'll get into in just a little while. But the primary takeaway here is, in addition to AWS provided build components and tests, there is the ability for you to author your own build components and tests, and we have a declarative YAML-based specification that allows you to do that. Furthermore, all of the AWS provided components, you can actually go ahead and read the YAML specification that associated with them. So what you could do is you can fork off one of those to customize it and build your own components and tests. The service also integrates with AWS License Manager, which is another peer AWS service that allows you to track and manage licenses. So in AWS License Manager, there is a construct called a license configuration, and license configurations are attached to AMIs. And once they're attached and the AMI is running, the License Manager service automatically tracks the use of licensed software that might be present inside of that AMI, so that you have one place to track license usage, so that if there are audits or true ups and things like that, you have you have a single pane of glass to track your license usage. So when you build armies with EC2 Image Builder, you can go ahead and associate license configurations that you might have created with AWS License Manager. Furthermore, if you already have license configurations that you might have attached to your source army, you can also list it. You can also view it as a listed license configuration during army customizations and make edits to that and things like that. The other key component here is the act of keeping these images up to date and patched. Like I mentioned, golden virtual machine images have a short shelf life. There was a colleague of mine who was once saying they have the shelf life of a banana, because that's how frequently new updates are available, and they're stale. So we allow for the ability to have a schedule, and again, it could be weekly, daily, multiple times a day, fortnightly, you name it. Or you can also go ahead and stick in a cron expression if that's more your style, and you can have this pipeline rerun at that stipulated cadence to pull in all of the latest updates. When it comes to the updates itself, we have a semantic versioning scheme, major, minor, and patch, to denote each of the constituent components here. So this includes both the source image, the tests, the hardening primitives, as well as the build components. So for example, I could go ahead and say, every Monday, for example, go ahead and build me an image that only includes updates that are represented by a patch version change, as opposed to major and minor version changes. Or I can go ahead and say, build me a new image with all of the latest updates, irrespective of if it's a major version change or a minor version change or a patch version change. And each of the artifacts that are managed by Image Factory are versioned, and it gives you the ability to version them. So that if there is a change, you can denote the extent of that change and take downstream action when you rebuild your images to ensure that they're up to date. Furthermore, you can also, on an ad hoc basis, manually trigger rebuilds of your image. You don't have to wait for the schedule, and then you can generate your own images. Another topic that I wanted to get into is the shared responsibility model for security. Now, all EC2 Image Builder operations run in your AWS account. So what we do is that behind the scenes, based on the specification for customizations and tests that you're provided, we spin up EC2 instances in your account where the operations to install software or change configurations or to run tests are made. And our position here is that ensuring the security of the custom armies is a shared responsibility between AWS and the customer. you own the security posture of the images that are produced, and we're committing to make a best effort to ensure that these images are secure by doing two things. One is we provide you with necessary ingredients that you can use to harden your images. For example, we have a STIG hardening specification. Furthermore, before these images are actually built, we do a thorough job, and we mandatorily enforce this of cleaning up things like residual credentials, things like bash history, etc. Or in Windows, in the case of Windows, we run sysprep to ensure that there are no residual artifacts that are left in place. Despite this, we recommend that you validate the security posture of the images that you produced, and the service EC2 Image Builder integrates with AWS Inspector that you can use to validate the compliance levels or sort of of these images that are produced. For example, Inspector comes with inbox support for validating against CIS benchmarks. It also helps warn you if there are unpatched CVEs in this image that represent an aberration from the preferred hardening state. And finally, we don't guarantee that the images produced with Image Builder are compliant with any regulatory standard ourselves, and it is a shared responsibility, and our recommendation is that you explicitly validate this with your compliance teams and with automated tools such as Inspector. There's also an identity and access management topic here, which is that since we use EC2 instances running in your account for the purposes of both customizing these images, hardening them, as well as running tests on them, it is important that the right IAM permissions are associated with that instance. So you attach an instance role to that instance, and we have a managed IAM policy that you can attach to that role that will govern, that will give it the requisite permissions for most image builder operations. However, if you have custom tests or custom build components, you will have to go ahead and ensure that you are providing the requisite permissions to that IAM role that you're attaching to the instance that will perform image customizations or will run tests in your account. Furthermore, there is a service linked role where that gives EC2 Image Builder the permission to operate in your AWS account, and so that this simplifies it. And the first time you create an EC2 Image Builder resource, the service link role gets created for you. Again, you can go to the IAM console and tweak around with the permissions associated with that service link role as well. Before I get to a demo right now, I want to quickly go over certain terms and constructs and concepts that are in EC2 Image Builder so that you can follow along. The first one is what we call a pipeline. So a pipeline represents the end-to-end automation that is needed to produce your images. It's associated with the build schedule, and it's also associated with this specification that we call a recipe. The best analogy that I can think of is if you're say baking an image, or if you're cooking up an image, there's a list of ingredients and a list of steps that you have to take, and that is what's stipulated in the recipe. So it includes the source image, the list of build components, the list of tests, what instance type you want to have running, IAM roles associated with that instance type, things like that. A build component, like I mentioned earlier, could be an AWS provided component that you use, or a custom component. This represents software that you want to install. It represents configurations that you want applied, or it could be scripts that you want run. A test is fairly self-explanatory. This could be any binary that you use for a test, as long as the requisite runtimes to run that binary are present in your image. The build schedule represents the cadence at which images are rebuilt. That you get to specify, and a managed image is essentially the output of an image factory pipeline that is constantly kept up to date. Again, there are AWS provided managed images that you can use as starting points. The other key construct, almost as a best practice that I will state here, is our recommendation is that you start with some of these managed images that we provide that are minimal in nature, so they don't have any of the a lot of pre-installed components and any of the unwanted bloat, so that you can not just build minimal images, but you can build images with just enough of the OS to support the applications that you care about, so that you can cut down on security attack surface and also unnecessary resource usage. And our service allows for both of that. So I want to quickly get into a demonstration of EC2 Image Builder, and I'm going to quickly switch over to my demo laptop. Alrighty, so for the purposes of this demo, here's what I'm going to do. Just to set a frame for this demo, as I give you a walkthrough of the service along with a specific purpose in mind. I'm going to start with a stock Amazon Linux 2 image. I want to install, say, Docker on it. The stock image doesn't come with Docker. I want to harden it to the STIG standard. STIG, again, comes with a low, medium, and high hardening standards. The high hardening standard is particularly has a high bar when it comes to locking down ports, removing unwanted components, etc. And finally, I want to run a bunch of basic tests and then distribute it to a few AWS regions that I care about. Furthermore, I want to ensure that this image is kept up to date and patched with the latest changes on a weekly cadence, say every Wednesday at 12 o'clock or something like that. So that is what I'll try and achieve with this demo. But as I go ahead and do that, I'll also walk you through the other aspects of the service. For the purposes of visual convenience, I'm going to use the UI console here, but everything that you see here you can also achieve with the command line or with our APIs. So since our pipeline is the basic construct here, so the launching point into the service is to create a pipeline and to define a recipe that represents essentially all of the activities that are performed by this pipeline. It indicates what your starting points are, what you add, etc. So we have curated experiences for Amazon, Linux, and Windows at this point in time. However, you can also start with any other OS image that has the SSM agent pre-installed as a custom ARMY that your account has access to. So if I were to select Windows for just a moment, I can go ahead and browse a list of managed images that we provide as AWS that represent good starting points for you to customize. So there is various versions of Windows Server. There is multiple versions with SQL Server pre-installed, etc. And this scrolls for I think a couple of pages. And then there are core versions which represent minimal images that you can add components to. Furthermore, we also provide AWS provided build components for PowerShell, core, PuTTY, commonly used pieces of software. Since what I'm looking to achieve here is building a Linux image, I'm going to switch back to Amazon Linux. So we have a curated Amazon Linux 2 managed image that I'm going to start with. I could also, for example, start with an Ubuntu image or it could be any other image that has the SSM agent pre-installed that I can start as a custom ARMY. And I'm also going to check this box that will sort of tell the service that every time there are updates to this image, as you can see, this image is versioned. There's X, Y, and sort of Z there. So it's major, minor, patch. So if every time there are updates to that, I can use that as a trigger to initiate a rebuild. Again, for Linux, we have a number of build components. So one of the build components is, say, a STIG specification for hardening. So I'm going to go ahead and select that. The other thing that I was looking for was Docker. So I found that right here. I'm going to select that. Oops. So, yeah, I have those two selected. We have a whole list of AWS provided tests. These could be simple boot tests to reboot tests to integrations with inspector, ENI attachment, EBS attachment, mechanisms to test the YUM repositories, etc., etc. This goes on for a few pages, but let's say I'm going to select, for the purposes of this demo, a simple boot test. And again, you'll notice that each of these components are versioned with major, minor, patch, and if there is a change there, you can use that as a trigger to initiate a rebuild or a rerun of your image pipeline. So I'm going to go ahead and select that. Furthermore, if I so desired, I could go ahead and create my own sort of build components as well. And there's a separate authoring experience here Again, we have an example that you can start from that provides you with at least a sample that you can start with. Furthermore, you can go ahead and inspect AWS provided build components that are provided here. Let's start with this one that installs Careto, which is Amazon's Java distribution. So the build component for this, the YAML file is available here that you can reuse and fork and for your own components. Our recommendation is that you have as many console messages as possible so that debugging becomes simpler. So getting back here, so I selected a bunch of AWS provided components, not selecting a custom component right now, but you can go ahead and author one if you so desire. I'm going to go hit next. I get to provide a name for my pipeline, so I'm going to say demo underscore reinvent. I'm going to skip the description. There's an IAM role that I'll have to attach to the instance that is being used to perform these image customizations, as well as subsequent to that, once the image is produced, another instance will be spun up to run the stipulated tests. And the IAM role attached to that, I can go ahead and specify this here. So I have a demo role that I'd pre-created with the managed IAM policy associated with the image builder service already attached to it. Then I go select my build schedule. This could be either a manually triggered build, or it could be a scheduled build, or I can provide a cron expression. I could, for example, say every Wednesday at, this is UTC time, so I don't know what that translates to, but yeah, say 12 o'clock UTC time, I want to rebuild that, that pipeline. I can also optionally go ahead and select a number of infrastructure settings. Now, if I don't select anything here, it will use sane defaults. Image Builder will default to EC2 defaults. So I think it is M5 large. So that would be the default instance type used for the customizations in your account. But if you so desire, you can also go ahead and select from a list of instance types that you want here. There are also lifecycle notifications that you can examine if you're using the UI console here, such as, all right, my pipeline is enabled, now it's building, now it's testing the image, etc. And you can get programmatic SNS notifications for these. So you can provide an SNS topic and listen to it, and you'll get notifications there. You can also go ahead and provide custom settings for VPC and security groups, etc. But this is the troubleshooting part is the one that I want to spend more time on. Now, in the happy day scenario, things will work great, which is that, all right, you have a pipeline and then it rebuilds fine, you get a golden image out the other end, the pipeline continues to run at the schedule that you have provided, so there'll be new golden images that are produced that are up to date. However, for whatever reason, it could be an issue with say, a custom component. Let's, as an example, if the build fails, then there is the ability to go ahead and troubleshoot the problem. And there are really three ways that you can go about doing it, almost like a funnel. The first one is the service itself will throw up a bunch of error strings around what went wrong that, again, provide actionable guidance for what might have likely gone wrong, especially if it's things like IAM permissions that might be lacking, etc. Especially if you're trying to pull binaries from S3 and then install them or write certain logs to S3, and if you don't have those permissions and things like that. But if there are more advanced issues, what you can do is you can uncheck this behavior, which is a default behavior that says terminate instance and failure. So by default, every time an image is produced, the instance that is used to produce that image is terminated. Now, that happens in both the success scenario and the failure scenario. Now, in the failure scenario, you can go ahead and say, do not terminate that instance if there is a failure. And then you can go select an EC2 key pair and connect to that instance and use SSM run command primitives, for example, to be able to do more advanced debugging and troubleshooting. Furthermore, every build component and test is associated with a console log and sort of a bunch of logging information that shows you the detailed behavior after each step. And you can go ahead and point to an S3 location, again in your account, and you'll also have to ensure that the IAM permissions are correctly set to be able to write to that S3 location. so that, again, you can look at those logs to enable you to debug and troubleshoot any issues that might have occurred. So that's the troubleshooting and the debugging behavior. So I'm going to go ahead to the next screen here. We spoke about AWS License Manager and license configurations. So the service allows you to associate license configurations that might be created with License Manager. In this specific account, I don't have any created, so it says it doesn't exist, but I could go ahead and create, this jump off to the License Manager console, create a license configuration, come associated with this image that I'm building, etc. Next, I specify my output AMI name, so I'm going to say demo. So I just give it a name, and I can also go ahead and specify tags for my AMI as key value pairs. Furthermore, since this is essentially the output of a pipeline, and the pipeline can produce multiple images. So every run of the pipeline will produce a new image, and this is an output name that is not unique. So what we do is we go ahead and we suffix the build time associated with this image to this name that you provided. So if you go to your EC2 console and list your images, you'll see sort of the name that you provided suffixed with the timestamp associated with when it got built. I'm going to skip sort of adding tags in this case, and then I'm going to go ahead and select say a few AWS regions, say US East 1. I can go ahead and distribute it to a bunch of places, but you get the idea. And finally, I can also go ahead and specify launch permissions. I can go make the AMI public, or I can keep it private and add the list of AWS account IDs that I want to provide launch permissions to be able to use this AMI. Then I say review. It essentially gives me a summary of all that I selected in the wizard that I walked you through. And then I go ahead and say create pipeline, and this will create an EC2 Image Builder pipeline. Now the pipeline itself, it just got created, but it's not running. So the pipeline says is enabled. So this was the pipeline that I just created. So this says it's enabled, which means it's active, but it's not running because it will only run at the stipulated time, which was I think Wednesday at 12 o'clock UTC time. So what I'm going to do for the purposes of this demo is I'm going to go into this pipeline and I'm going to say actions and explicitly manually run this pipeline. And the pipeline execution says has initiated successfully. And one of the things that I can do here is now I've gone back to my EC2 console, and I'm going to go look at the list of running instances here. And in a short while, you'll notice that when the pipeline execution has started, a new EC2 instance will get spun up to perform the customizations that I've specified with the source image that I provided, with the build components that I selected, and then that instance will then get cleaned up and then snapshotted to produce the AMI that I provided. So let me quickly go do a refresh of that. So yeah, so it says this version of the pipeline is currently building in the status. And I navigate back to my EC2 console and I hit refresh. And let me sort of expand out this. So I don't know if folks at the back can read the text, but it says there's a new instance that's created with sort of the name that I provided, which is demo underscore reinvent, and the recipe associated with that. And that image is, or that virtual machine to customize that is running. And the IAM role that I selected was applied there. Now, in a short while, now this will take a short while, what you'll see is that this instance will terminate and a new instance will start. So what would happen is this instance would terminate after cleaning up all of the credentials, snapshotting to produce the image that based on the specification that was provided. And then a new instance would start to run a test on it. And then I think the name of that would be test instance for demo underscore reinvent, so on. And the test would run, and then in EC2 Image Builder, the status would change to, from building, it would change to testing, and then it would show done, along with the ARMY ID that would then be generated. And yeah, we'll wait for this to actually go through. And so in the interim, what I want to show you is other parts of EC2 Image Builder. So when you look at EC2, excuse me, when you look at image pipelines, you can look at all of the pipelines that were created. You can look at the recipes associated with those pipelines that could be used to create the pipeline. You can sort the recipes by OS. And more importantly, you can look at recipes that were created by me or recipes that were shared with me, which could be other parts of my organizations or other AWS accounts that explicitly chose to share this recipe with me so that I can go ahead and create a new pipeline with it. And that sharing is possible through the Resource Access Manager service. Finally, there are components. Again, there are two kinds of components. There are build components and there are tests. Again, there are those that are created by me, there are those that are shared with me, there are those that are provided by AWS. Like I showed you earlier, the ones that are provided by AWS also provide the full listing of the declarative YAML that you can use as a reference to build your own custom components. These are MIT licensed and provided here. And finally, there is the ability to go look at the images. So, I have lots of pipelines that I'd created, and each of these would have created images based on when they were run. So this is essentially the same demo that I ran a half an hour before this session started. So you'll notice that there is an AMI that was produced, again, using an identical pipeline. If I go to my EC2 console, you'll notice it's still building. But if I go to my armies, you'll notice that the army that I'd previously built using a prior pipeline would show up here. Oops. And I can go ahead and spin up an EC2 instance, connect to it, and show you the changes. But as this image is building, one of the things that I'll do is I'll quickly get back to the slide deck to go over some of the other topics that I wanted to cover, and then get back to this and see where this is at. So we went over debugging and troubleshooting. Again, there are three ways here. There is the ability to use the console and console messages to be able to know what's happening. You can export logs to S3 for each step, and finally you can connect to failed instances and debug them using SSM run command. I also wanted to go over sort of an example of a log file for debugging. We don't have too much time, so I won't get into all of the details here, but this is an example of, say, a log file that was generated for a Windows build. Again, I was running a bunch of PowerShell scripts, and I've sort of labeled them as happy step and an unhappy step, and I'd also taken sort of note to put out messages to standard out and standard error that will go into another file .console.log, but it's also listed here that I can use to try and debug any issues and to localize the source of the issue to a specific component. Furthermore, once I've localized the issues, I can go connect to that EC2 instance and attempt to remediate it as well. With regard to pricing, this is an important topic. The service is available at no cost. So it is, we don't charge for it at all. Since all of the operations are run in your AWS account, you will incur sort of the costs for the resources used by the service. So for example, the EC2 instance is used to customize your images, to test your images, any S3 usage to store logs, things of that nature would get charged. And the other thing to be mindful of here is that the EC2 images or the EC2 instances used to customize and test your images are ephemeral in nature. So they come up once the image building is done, they are terminated, and then they go away. So it's not a long-running instance. So that's another thing to be mindful of. So as this demo is progressing, it's still in the building phase. So what I'm going to do is I'm going to quickly summarize EC2 Image Builder for you. So this is a brand new service that enables you to produce automation to build images easily and quickly. It helps you raise your security bar by ensuring that you can keep your images tested and up to date. More specifically, you can apply all of the latest pending security updates, and when there are security updates, you can trigger rebuilds of your image pipeline so that all of them are applied. You can run tests. Again, there's a suite of AWS provided tests, or you can also run your own custom tests. Using VM ImportExport, you can use the service to build images not just for use on EC2 and on AWS, but also for use on premises. And finally, it's available at no cost. It runs in your account, and you only get charged for the resources consumed by the service on behalf of you. So I'm looking at this. This is still building. So in the meantime, what I'm going to do is, we have a few minutes left, so I'm going to take questions now, and then see if this image is done building, in which case we'll get back to it and I can show you how it works out. Let's start here. Yeah.
Where do you suggest we separate code from actual OS stuff? Because it's easier to use both AMIs even with application code, right? So where do you suggest we actually do the separation of just OS stuff and application stuff?
All right. So the question was, where do you separate out OS-related operations and application-related operations? And really the guidance is, the OS-related stuff is already pre-contained for the most part in the source image that you provide, and the build component, so that notion of build components really encapsulates, for the most part, applications, scripts, configurations, etc. So that is the separation of concerns that at least we see. But it is true that it is a blurry line. You can have stuff that run across the two, but yeah, that is the separation that at least the service recommends. Start there. Yeah. So the question is, are we going to provide CIS as a built-in test? As of right now, as I speak right now, it isn't available as a built-in test. We have a STIG standard. However, you can use AWS Inspector to test for compliance against the CIS standard. Having said that, providing additional hardening primitives and security or mechanisms to achieve commonly used security benchmarks is big on our radar, and is something that we hopefully want to get to quickly in due course. So, yeah, we'll start there.
You created the image, you selected a specific accounts that are going to be shared with the image with shared content. If you create new accounts, how will that image share itself to them?
Certainly. So the question was, in this demo, what I did was I shared I didn't share, I could have provided launch permissions for specific AWS accounts. The question was, if there are additional accounts, how do I go retroactively add them to that? So that launch permissions experience that you saw is something that is sort of embedded in the image builder console. You can achieve significantly richer and more sophisticated experience if you go to the Resource Access Manager console, where you can actually share that image itself, share that AMI itself with multiple accounts. And then there's the organizations integration as well that will allow you to share it across from master accounts through to member accounts, and do more advanced sharing. That is not something that I showed, but that is something that is possible. Let's start here and then I'll get to you. Yeah. So the question was, is there any plans to support Red Hat AMIs? I'll say this, in principle, the service doesn't preclude you from doing that already. If you have an existing OS image with the SSM agent pre-installed, you can choose it as a custom AMI and go ahead and customize it. However, when it comes to providing additional OSs as managed images and providing a curated workflow with AWS provided build components and tests, it is something that's on our radar, and our intention is to expand out the surface of OSs that we provide curated experiences for. Don't have dates to talk about, but our intent is certainly to expand out the list of OSs. Go there. Yeah. Certainly. So the question was, what about the integration with say, tags for additional resources? The only thing that I showed you here was tags for at the Army level, not tags for additional artifacts. The short answer is yes. It's not. If you use the CLI or the API, those are some things that you'll see more prominently in the UI experience, at least in the UI that we currently have. It isn't prominently called out. Yeah, go ahead. So the question was, how can you bring images back on premises? There's another capability called VM ImportExport that currently is sort of a separate step that you have to do. So you point it to an AMI, and then you point it to a target format. It could be a VMDK, a VHDX, or an OVF, and then it converts it to that format, and then you can bring it on-prem. It is an additional step, and it is in our intention to make that flow a little more seamless than it is. Go ahead. So the question is, how does this extend to encrypted AMIs? So when it comes to encryption of images, there are really two ways to go about it. One is you can use full disk encryption technologies that might be inside the OS itself, like for example BitLocker in Windows or eCryptFS in Linux, and essentially apply that encryption as a build component, and then the ARMY is encrypted from the inside. The other way to do that is to encrypt the ARMY itself as an artifact from the outside. EBS and technologies like EBS support image encryption. So right now, as I stand here and speak, we don't have the ability for the key management integration to be able to hook up with KMS and share those encrypted ARMYs if you encrypt it from the outside. It is something that is in our intentions to get to. It's big on our radar. We recognize the need for that scenario, especially for enterprise use cases, especially if you have secrets in these ARMYs and things like that. Right now, as we speak, it's not there. It is very much in our intention to address that in due course. So, yeah. All right, go ahead. Certainly. So the question was, does this use Systems Manager on the back end? And if yes, can you go ahead and sort of manually sort of tweak and manipulate Systems Manager or access at the Systems Manager constructs? The short answer is yes. From an implementation perspective, there are some dependencies on Systems Manager. Right now, as we speak, we don't really provide that full ability for you to go manipulate the underlying constructs itself. Again, we're interested in feedback. If that is a scenario that you're interested in, happy to chat with you offline to understand your needs there, so that yeah, we capture those needs as we look to iterate on the product. So, yeah. All right, go ahead. So the question was, if I want to write my custom tests, what language does it support? So one of the things is, I mean, if you notice some of those primitives, it is execute binary. So it could be any binary. It could be, if it's Linux, it could be any ELF compatible binary. I could write it in C. It could be anything really, as long as the requisite dependencies to run that binary are available. It could be a Java program, but I'll need to have Java installed. It could be Python. I'll need the Python runtime. We also provide native constructs for running PowerShell scripts and Bash scripts. And especially with PowerShell core, we've seen with a lot of customers that have heterogeneous fleets with Windows and Linux that that is a common bridge that they can use. But yes, it's PowerShell, it's Bash, but you can also run any binary. But you will have to ensure that the requisite dependencies to run that binary when it comes to language runtimes or C libraries and things like that are in that image. So the question is, it supports Inspector. Does it support additional scanning tools? The short answer is yes, you can integrate it with, I mean, if you use it from the API, you can use it to call out to other scanning mechanisms as well. Inspector itself has a modular model that allows you to to be able to use other third-party tools as well. Yeah, go ahead.
If Inspector has findings, can you fail the build?
So the question is, can you fail the build if certain tests do not pass? Short answer is that is something that's very big on our radar as we speak. I think a lot of the questions were themed around what are we doing next? And really, there are some key areas of focus here. One is around expanding out the list of OSs that we provide curated experiences for, encrypted images, and sharing, integration with, say, infrastructure as code primitives like CloudFormation, CDK, etc., as well as sort of expanding out the list of primitives that we provide as AWS. You mentioned a few standards. There are other hardening primitives, etc., as well as testing tools. Yeah. I'm going to again quickly do a check to see if I think we're close to the end of time. So what I'll do is I'll hang around, and I think the build has just completed and the test is just about to complete. So we will be able to look at it in just a little while, but since we're I think we're over by a minute, I'm going to hang around here, and if you have any additional questions or feedback, happy to talk to you and go over them. But thank you so much for attending. It was great to talk to you about it. So.